So last time you guys told that Matplotlib has not been taught. Also, there is another library, Seaborn, which you should know in data visualization. So we will see both Matplotlib and Seaborn today. Okay, so yeah, we'll go to the official tutorials of Matplotlib and the user guide and tutorial of Seaborn. Okay. So Matplotlib is the basic library which you should know when you are using Python for simple plotting. Now you can import Matplotlib as, so you can say import Matplotlib is basically evolved from MATLAB. So those of you who know MATLAB, the syntax is very similar to MATLAB for the Matplotlib syntax is very similar. That's what I mean to say. So yeah, so you can, so this is yeah, rather than importing directly, importing Matplotlib directly, you would be using this command, this syntax most frequently. You would say matplotlib dot pyplot as plt. Okay, and then you can see we are also importing numpy. So just to make a simple line graph, you will have to give, so the way you define or you create a figure in Matplotlib is, so you say plt dot subplots, and plt dot subplots, it returns fig and an axis. So we will also see, no. So we will see all the, okay, all the visualization libraries today. Carto. Okay. Yeah. So you can so you create your figure using plt.subplots. It returns you figure, and in this case we just have one axis, but you can define the number of subplots you want in a figure, and then you will get either a vector of axis which you can use as ax and square bracket 0 square bracket 1 2 3, or you, if you are using a two-dimensional or you are making a grid of like we will see that, so then you will get a 2D axis. So the way, simply, if you want to plot a line, either you can provide a list or a numpy array. So here you can see this, you have to first provide an x and you have to provide a y. So for every x, so 1 comma 1 and 2 comma 4. So when x is equal to 2, y is equal to 4, x equal to 3, y is equal to 2, x equal to 4, y is equal to 3. Now these are the different components of a Matplotlib figure. So we have the title at the top. So we'll see how to give the title, and this is known as the legend. The background, if you want the grids, so these dotted lines are the grids. If you are making a plot which is continuous, it's called the line plot. The dots are known as markers, or these are the scatter plots. And your so these two are your axes. Okay, so these are your axes. You can also make like two plots on a single plot. You can have like one y-axis and another y-axis. So like the right vertical line also can be your axis, and these edges are also called spines. Okay, and then your text on your this one is the x-axis label, this is your y-axis label, and then these are your ticks. So we call them the major ticks. You have major ticks and you have minor ticks. So also you have labels. So if you want to, so you can see the number 3 here, 2 here. So these are y tick label. So why I am saying all these things is you'll come to know very soon. We'll be using the syntax. So here you can see so this there is a label to the minor x tick, label to the minor ticks as well. So then this is the major tick. Now plt.figure is also like plt.subplots, but if you don't pass anything to plt.subplots, then plt.figure is same, like it just doesn't return an axis, but otherwise it is same. And but plt.subplots, you also have the feature of making a grid of axis. So you can see from here, if you want a 2 by 2, so like if you want 4 subplots, you can pass the arguments, like the first 2 arguments correspond to the kind of subplots you want to make. So this will make a 2 by 2, basically 4 subplots, plt.subplots to 2 comma 2. Now let us say that you have B, you have made as a matrix 1, 2, 3, 4, and you transform it as an array. And okay, so we are having a random number seed, and you are creating a data dictionary, which is having the key A, C, and D. And you can see A is np.arrange 50, C is np.random.randint 0 to 50, and how many you want. So you would basically generate 50 numbers between 0 to 50, and then np.random.rand 50, this basically generates 50 random numbers. So then you do some manipulation on B, and okay, so you make B here. So you are making this key B, and here you are modifying D. So now you can see that we are defining. So we are saying fig comma axis. So ax equal to plt.subplots. So plt.subplots will return figure and axis uh, objects, and you can give a keyword corresponding to fixed size, uh, fixed size. So this size is in I think inches, so 5 inches by, I think so, inches, but we'll need to confirm, yeah. And you can also give the layout. So then if you give ax dot scatter a, so you see a comma b, and what is the c, and this s is the size. Okay, and you give this dictionary data equal to data. So what it will do is corresponding to a and b. So you can see corresponding to each a and b, it will uh, it will plot it will plot scatter plot, okay, whose color will be represented, I think, yeah, this is, let us check. So here C is the color. So the color is represented by C. Okay, so uh, these colors that you can see, they are generated randomly, and the size of the marker, that is D. Okay, so you can say A comma B comma C equal to this key, and D equal to S size equal to this one, and what is your data dictionary. And now if you want to provide label on x-axis and y-axis, you have to use this syntax set x label. And in the argument you have to give the string, and similarly set y label. So if you are not, so this is when you are using plt.subplots. If you are using plt.figure, and so then you will directly say, because then you will not get any access, then it's just a single figure you are plotting. So you will say plt dot x label, so then the function is dot x label. But if you are having, if you are, so ax is also known as the handle of this subplot. So if you are applying the x label on this handle, so then you will have to use the set x label and set underscore y label. So now let us see. Let us say that you generate 100 numbers from 0 to 2, which are using np.linspace, and you generate this figure fig.ax equal to plt.subplots layout equal to constraint. So first you plot, you say ax dot plot x comma x. So you see this line, it's plotting this line. Now you have this, you can, so if you can plot multiple plots on the same, in the same figure, but for that you will have to give something known as label. Okay, so the label that we are giving for this is linear. So you can say x comma x square, so x star star 2 label equal to quadratic. So then you see this orange one is your quadratic, and x comma x cube label equal to cubic. But now once you give your labels, by default Matplotlib will not give you this legend. You will have to say ax dot legend, so then only it will show the legend. So if you are having multiple plots, it's important to provide the legend, and you are also setting your x label and y label. So you can also, okay, so what is the difference? Yeah, these two plots are similar only. Yeah, so you can also, what you can do is, so yeah, this is an example of, so you create these four data sets: data 1, data 2, data 3, data 4 equal to np.random.randn 4 comma 100. So this will create four uh, four like matrix of size 4 by 100, and if you return it to four arrays or four numpy arrays, it will assign the 100 of vectors of size 100 to each of these data 1, data 2, data 3, and data 4. Now, if you can, so herein, so they are showing that you can return, or you can say multiple axes, or you can just, if you just pass one here, like just ax, then you will have to index that ax. But you can also do it like this, like as a tuple. And we are saying plt.subplots 1 comma 2. So we have one row and two columns, and what is the fixed size? So generally 8 by 11 is the size of an A4 sheet. So if you are using the plots for your publications, so that is the maximum that you should go for. And you can create some kind of functions. So like my plotter, this is a function. This takes in in the argument an axis. So you have in this function, the first argument is axis, the second argument is data 1, third argument is data 2. So you can see data 1 comma data 2, and marker equal to x. So you can give the marker. So in PLT, in the plot function, wherein you can either plot lines, or you can use a lot. So with the lines you can use different markers. So different markers are available, like you can have this x, or you can have the filled circles. So these are provided as a parameter dictionary. So you can see ax dot plot data 1 comma data 2. So in this one also, so when this data 3 and data 4 are passed, so data 1 becomes data 3, data 2 becomes data 4, and it is returning, yeah, with the this whatever it comes out as from this. We'll see why we need to return this. Like plots when we need color bars. So we would need to get things in return from the plots. Now, so they're saying most plotting methods have styling options for artists. And in the plot below, we manually set the color, line width, and line style of the artist created by the plot. So you can see that fig dot comma axis, you create this figure, and x equal to np dot arrange length of data one. So this data one is what they're talking about. So length is 100. So np dot arrange 100 will create 100 numbers starting with 0. And ax dot plot and np dot cumulative sum. I think this cumulative sum, this will, yeah, we'll check this function. So and numpy dot come sum will return the cumulative sum of the elements along the given axis. So if you have an array, numpy dot array 1 2 3 4 5 6, so np.come sum will give you 1 3 6 10. Oh yeah, so this will basically keep on summing your numbers up to like whatever length you get. So the first number is 1, and 1 plus 2 is 3, 1 plus 2 plus 3 is 6, then 1 plus 2 plus 3 plus 4 is 10, plus 5 is 6 15, plus 6 is 21. So that's what they're doing here. So x comma np dot come sum comma color equal to blue. So you can see this is the color equal to blue. You can set the line width with this line width parameter or line width argument, and you can set the style of that line also. And you can set the color orange, and again x common np dot come sum color equal to orange, line width equal to 2. So you can see that this data 1 and data 2, these were basically random numbers from 0 to 1. So from actually -1 to 1, -1 to 1 it should do, but yeah, I mean that one you can check. So it will create some kind of random numbers, and these are like data 1 and data 2 plotted. So when you have this scatter plot, so you can say data 1 comma data 2, what is the size? So if you just give one size, let's say s equal to 50, or you can give an array of the size. So each of the, or based on the value, what should be the size. So that will be the size of these markers, and you can give the face color and the edge color. So edge color is k, so k represents black here. So you can see it has got a black boundary, and face color is c0. So this is the face, like the filling color of the filling. You can also have the different type of markers, o, d, v, s. So you can see this circle represents O, this rhombus type of thing is D, then this is V, and then this is, I think this represents square, this represents some kind of triangle. And so you can label these plots. You can say ax dot x label, set x label, set underscore y label. So Matplotlib has got this hist function. If you want to plot the histogram, which is if you have just okay, so mu, and so they are creating a distribution with mean as 115, standard deviation as 15. And if you create x equal to mu plus sigma np dot random dot random, so you create 10,000 numbers, a distribution with the 10,000 numbers, and you can plot this using ax.hist. You have to provide the data array first, comma, this is the number of bins in which this data will be created. So these bins will be equal in number. And this will correspond correspond to like if the numbers are going from 0 to 100, and you give the so it will be some custom bins. So then what should be the density? Density is like if you sum these numbers, so these columns or the probability. So let's say a number 5 is coming 10 times, right? So on the x-axis corresponding to 5, you will plot the probability of the number of times that number comes. So this y-axis you can see is the probability. So when we say density equal to 1 means that the total integration or the sum of all these numbers will sum to 1. And you can provide the phase color equal to C0. Alpha is the transparency. So you can even have multiple such kind of hist plots, and you can set the transparency, like how much transparent you want to keep. And you can also plot, write some kind of text on these on your plots anywhere actually in Matplotlib, but you have to give the on the x-axis where that plot should be. So you can see this one starts at 75, comma 0.025. So this is on x-axis it's 75, on y-axis it is 0.25, and whatever text you want to write, you just give in single quotes. Here they are using the math library, so it's coming in dollars. So in dollars, backslash mu stands for mu, backslash sigma stands for the sigma, the Greek sigma. And so you say ax dot axis 55, 170. So you can also give the range of the plot. So from where to where it should lie. So this is starting from 55, going up to 175 on the x-axis, and starting from 0 and going up to 0.03 on the y-axis. So you can also annotate points on a plot, often by connecting an arrow. So you can see here we have this np.arrange 0 to 5, 0.01. So you create numbers from 0 to 5 with spacing of 0.01. And this is your x, which is, let's say, time. And then s is your cosine of 2 pi t. So you are creating cosine function. And we are saying line equal to x dot plot t comma s. So on x-axis is time, y-axis is cos of 2 pi t. Line width, by the way, also can be represented by LW. So that is equal to 2. Now you can say ax dot you have to provide that you have to provide is a string. So where you want to annotate this, so you want to annotate this x comma y equal to 2 comma 1. So the location in this plot, so 2, and this is 1, and where the text should be, so xy text equal to, so this is starting at 3 comma 1.5, and arrow props equal to so you have to provide a dictionary. So some kind of you want to give. So what is the face color? So for the arrow, what should be the face color, and you shrink it. So provide an argument shrink equal to 0.05. And just like we saw, there was the axis function. There is the set xlim, set underscore xlim, and set underscore ylim. So if you just want to set the limits of a single axis, so you can use, or in this case, y-axis, so you can say x dot set underscore ylim equal to -2 to 2. Now, we have seen if you want to provide a legend, you legend. And now, okay, if you want to provide the ticks, or if you want to say scale, okay, so sometimes you would want to make your data in logarithmic scale. So for example, here you have some x data, and then you have this data. So you say ax 0. So herein you can see now we are having 5, axs equal to plt.subplots, 1 row and 2 columns. So now you can see we are accessing these plots with ax0 and ax1, and you plot, you make the same. So you, for the first plot is just a simple plot, uh, and the second plot, so it should be actually ax. And the second plot, okay, first they are setting the scale. So y scale, so you can say set underscore y scale log. So you can see the y axis has the scale is now in a logarithmic scale. And then you say ax1 dot plot x data comma y data. So now will be plotted on the log scale. So then you have the tick locators and formatters. So we have the data. So AX0. So now in this one you can see we have 2 rows and 1 column. So 2 rows and 1 column, and this size by default it just takes some size, but otherwise you can also provide fixed size here. So AX0 dot plot x data comma data. So this is that, and then ax0 dot set title. So here you can see you are getting this title. Now ax1 dot plot. So you are plotting this, and so this one by default it has provided these ticks. Matplotlib has provided for you. You can also manually provide the ticks. So you can say set underscore x ticks np dot arrange 0 to 100 comma 30. But every 30, so 0 np dot array 0 to 100 comma 0 comma 100 comma 30 will give you 0, 30, 60, 90. And you can also provide the like exactly what all ticks you want. So you say, for example, 0, 30, 60, 90. So you can see here we are manually changing the ticks. Now you can also plot the dates. So for that, NumPy's datetime library you can use, or date. So there are three things actually when you are talking in for dates. So there is one NumPy datetime. Okay. Then there is another library datetime, which you should try to use most of the times, because that is like this datetime library. It's like a very comprehensive datetime library. And then there is a pandas datetime library, which is having an interface, or very comfortably you can. So this pandas datetime, I think it is wrapping up the datetime library only. And so you can, even in xarray, this pandas datetime can be used very easily. So if you are having some datetime data, so you see dates equal to np.arrange np.datetime 64. Date starts from 15th of November 2021. So this is the start date. This is the end date, 25th of December 2021. And np.time delta. So time delta you are providing as 1, but the unit says hour. So this is an hourly data starting from 15th of November, ending at 25th of December. And then data equal to np.comsum, np.random. So you also, so this is, so these dates, so they have made these data sets in a way that these dates and the data, they're having the same length. So you generate some random numbers, and you say ax.plot dates comma data. So you can see that on on the x-axis, so you have 15, 22, and then this is where December starts. So then 8th, 15th, 22nd. So this one. So Matplotlib has provided a nice uh, tick labels on the x-axis corresponding to times. So you can see here, like they are also providing this. So for the formatting, MPL was matplotlib.dates.concise date formatter ax.axis.get major locator. So actually, if you are using xarray, you will not face all the, like, xarray will automatically do all this formatting stuff for you. Now, if you want to make a bar plot, so if you have, for example, these are the categories we have: turnips, rutabaga, cucumber, pumpkins, and then you are generating some random numbers. So categories, comma, these are the random numbers. Ax dot bar. This is known as the bar plot, and so there are additional axis objects. Plotting data of different magnitude in one chart may require an additional y-axis. Yeah, so this is when you want an additional y-axis. Such an axis can be created by using twinks to add a new axis with an invisible x-axis, and y-axis is positioned on the right. So, for example, here you can see we are creating two subplots, one row and two columns, and we are calling them ax1 and ax3. So in the first one we are saying ax1 dot plot t comma s. So you see this is sign of that L left. So this is that plot. Now ax2 you are saying ax2 equal to ax1 dot twinks. So now ax2 is will be having this as the y-axis and this is the x-axis, and L2 equal to ax2 dot plot t comma range length of t. So this is what your ax2 plot will be, and ax2 dot legend L1 comma L2 sign left comma. So for you can plot the legend for even ax1, that is fine. That is a choice that you have. And so yeah, so that is that if you would want to plot on the same plot using both the like left and y axis, and then you can also plot this kind of 3D plots. So this is basically having an x and a y, and now you also have a third dimension wherein you have a value. So for that you use, there are different functions. One is p color mesh. So you can see, yeah, this is, so you are in this one we are creating, so 2 by 2 grid. So we are creating four subplots. Now to access this subplots, you have to use square bracket I comma j. So we are using this first subplot axs 0 comma 0 p color mesh. So you have to provide x y will be, so it will be a numpy dot mesh grid. So you have to provide like two vectors there, like corresponding to x and y, and z will be your uh, 3D variable. So basically it will have two axes, and you will have value at each of the grid point. So you can use p color mesh x comma y comma z, and you have to provide the vmin vmax. So you can see vmin is -1, vmax is 1, and now you have to say, okay, so what is the color map. So you can see matplotlib color maps. So the Matplotlib provides different color maps. So you can see you can choose from the various color maps that Matplotlib provides. There are many out there. You can also create your own custom color map. So in this one, they are using this red, blue, and if you want to invert a color map, so you have to say underscore R. Okay, so by default, this red, blue, it starts from red, goes to blue. But now here, if you want the inverse of that, so you have to say underscore R. And okay, yeah, so that's it. So then if you also want the color bar, so if you remember, we were saying why we need this fig and why we need this return object from the plot. So you see, we'll use that now. So fig dot color bar, we are saying pc comma ax equal to this axs 0 comma 0, or you can also say axs 0 comma 0 dot color bar. So and then you have to provide PC handle for the first plot. So then you have contour f. So contour f looks like something like this. and then you can, so in that also you have to provide x comma y comma z, and you have to provide the levels. So the levels are like the in the, so in the plot or in the color map, from where to where the values will go. So it's going from -1.25 to 1.25. And you can see fig dot color bar. So you're passing this handle of the plot, and you're saying ax equal to axs 0 comma 1, and you are also setting the title. So this is the title. Now you also, there is also another function known as imshow. So imshow, you just provide this number. So this the 3D variable z square into 100. The color map is plasma, and so it's saying norm equal to, so it starts from, so vmin is 0.01, vmax is 100. So it's a logarithmic plot. If you want a logarithmic scale, so then you can provide, like, you can do various things with this norm, but you can also plot this like as a logarithmic color bar. And then we have the scatter plot. Scatter plot will plot exactly the points. So these three plots are showing you some kind of an interpolated version of what you can see in the scatter plot. So the values are represented by the color, and the location is represented by these x comma y mesh grid. So yeah, and then you can also have different mosaic of your subplot. So you can say plt dot subplot underscore mosaic. Now upper left, so you can say upper left comma right, and lower left comma right. So you have this as upper left, lower left, and this is your right subplot. Okay, so this was a basic usage tutorial, and if you have any questions, you can ask that now before we start this pipeplot tutorial, which is like very simple and intuitive, similar to what we have seen. So you can say import matplotlib.pyplot as plt.plot. If you will just say plt.plot, it will plot these some numbers, and on x-axis it will plot the indices. So there, or you can say like provide custom x and y, and then you can have so you can provide, like if you want to plot the some kind of a scatter plot, so or you can just say plt.plot, and you can give the type of, so this r represents the color, which is red, and o represents the shape or the marker. So you can have different styles of the markers. So you can say so this is, I think syntax is similar to Matlab also. So you can say plt.plot t comma t r minus minus. So this will plot this line comma t square, and this is blue, and square, the shape is square, t comma t cube, and this is color is green, and the shape is this kind of a triangle. And we have already seen this scatter a b c is the color, s is the size, and you can plot these bar plots. You can have the scatter plots and the normal plots. So we'll not go into these details. Yeah, these are mostly similar things. We have seen how to plot a histogram, how to annotate text. So you have to provide, so plt dot annotate. So here in this case, you see we are just saying plt dot subplot. So it just returns an axis and not a figure. So you want to say where you want to annotate, where should the text be, annotating text be, and what are the properties of arrow. So arrow props equal to, you have to provide the dictionary. And you can plot in log scale. So you have to say plt dot whatever axis you want to make into linear or log. So you have to say plt dot y scale log, or you can even say plt dot x scale log. So this is what this is. The I think we'll move on to Seaborn. So Seaborn is is a library which you can use to plot. It's got a very good integration with pandas, and the plots are visually appealing. Seaborn plots are visually appealing relative to Matplotlib. So Seaborn you will import as using this one. Import Seaborn as SNS. So there is some tutorial data set. So this is that tips. So this is a pandas data frame. Now if you want to plot a scatter plot, so the default kind is, so the scatter plot is a default kind in replot. So this is rel plot. You have to say what is the X column in this tips data set, what is a Y column to use, and then you say data equal to tips. So whatever this is, either if this is df, so you have to say data equal to df. Now you can also use something known as hue. Okay, so if you want to segregate the data sets based on another column, which is a column in the data frame tips, so you want to divide this based on whether the person, so smoker column has values yes and no. So you can see that this is now divided into two parts. And so you can use the style. So the style can be based on based on the smoker. So by default it is picking up this these markers cross and the circle markers. And you can also do something like hue is, or some maybe some other column. So basically this cross represents dinner for and the color represents whether person is a smoker or not. So this is not a smoker, but this is dinner, and the total bill is around somewhere around 50, and what is the tip that they are providing. So that's what you can do with rel plot. And you can also give the hue as the size. So what is the size? So size is another column. So you can see that this data is divided based on this on size. And you can change the palette. So you can say, yeah, this is a palette. Okay. So you can also provide this size argument based on a particular column. So this will change based on that. So the size of the marker is changing uh, based on the size column. You can also have the sizes from 15 to 200. So the range of the sizes is going from 15 to 200. Okay, so you can also say the type of plot using this word, this keyword kind. So you see kind equal to line. So it Seaborn automatically picks up the X label, Y label from the name of the column, and you can, yeah. So this is another kind equal to line plot, and it's so in this plot, so you have X equal to time point, Y equal to some kind of signal, and so some data sets. So for example, there might be for a particular time, there are, for example, many signal values. So Seaborn has on its own, so default behavior is to aggregate, and it plots. So this is the mean, and the 95% confidence interval it's plotting. you can say confidence equal interval equal to none. So it will just plot the mean for you. You can say the confidence interval that you would want. Maybe it's a standard deviation. So you can say, so this is what it has plotted now. And so you can set the estimator parameter to none. This might produce a strange effect when the data have multiple observations at each point. Or you can say, so you can divide this as well. So based on the based on some other column, so you can say hue equal to event, so stem or q, so these are the two events, and kind equal to line. So this one still we are seeing rel plot. And so you can say that, okay, so same thing, style is based on event, hue is based on region, and the markers, so you can also set the markers as true. So this will basically use the markers for the style. Okay, so we will, yeah, yeah, this one we have seen now. This kind of plotting functions, and so you can, just like Matplotlib, you can have this kind of different subplots using Seaborn. I think, yeah, we have covered the basics. You can see the other things. Yeah, one important thing that I would like to show is this pair plot. So if you just say SNS dot pair plot and you pass a data frame, so this will plot like for every uh, and you can provide species, or it will even take species as one of the column. So these are the different columns: sepal length, sepal width, petal length, petal width. So you can see that for the, like, for the sepal length and sepal length, it's providing you the distribution based on the distribution of the sepal lengths based on the different species, and rest are the scatter plot. So this scatter plot has on x-axis sepal length, sepal width. You can also say, like, if you would want to plot a KDE plot. So these distributions, if you want to uh, use the KDE distribution. And okay, so this SNS dot pair grid, if you just provide this the data frame, so it will plot these kind of distributions for the same variable, and joint distributions also it will plot for you. So that is, you can do different things in Seaborn. And then there is another library known as Plotly. Okay, so Plotly is a very nice library if you would want some kind of interactive plots. So Plotly you will use as import plotly.express as px. And if you would want to plot a bar plot in Plotly, so you say px.bar x equal to, yeah, abc, y equal to 1 3 2. And so you can see that this is the, yeah, not this one. Yeah, this is the Plotly plot. So you can hover over the Plotly plot, and it will show you the values as well. And rather than using plotly.express as px, most of the times you will use plotly.graph underscore objects as go. So let us see if they have some example for that. Hmm. Yeah, so these are some of the examples that uh, you can see have been made using Plotly. For example, we'll see this sun sunburst plot with Plotly Express. Yeah, not Plotly Express. Let us see if we can see some Plotly Go plot. Graphics objects. Yeah, even this is using Plotly.express. But anyways, so yeah, we can spend more time on this, but that is depending upon whether you guys want me to spend more time on Plotly. So you can see that the this data is the wind data is there in Plotly for tutorial purposes, and you can say px. So px is plotly.express. So px dot bar underscore polar. So this is a polar plot. You are passing this data frame. What is the r? So r theta. So r is the frequency. So how many times? So that is so if that so in this case uh, so this in this direction west northwest, so the wind, for example, the wind is happening more times than as compared to in the east direction. So r is the frequency, so r is the radius. Theta, so this is, then we have the theta column, theta equal to direction, the color equal to strength. Template, you can use some, there are different templates in Plotly. And so also color underscore discrete underscore sequence. So you are using this plasma color map, so and a reverse of plasma. So you can see that you can hover over this windrows diagram, and so you can also say, okay, so fig equal to go dot figure. So showing this using graph objects. So plotly dot graph objects as go, fig equal to go dot figure, fig dot add trace. So if you would want to add one like one figure to plotly or to that figure, so you would say, always say add trace, and within add trace you would say go, which you have got from here, go dot bar polar. So in this case we are plotting this polar plot, and what are the radiuses, and what is the name. So 11 to 14 meter per second. So these are the radius, and this is the marker color. So you can see that these so these are have been provided, and so similarly you can have 8 to 11 meter per second, 5 to 8, and then less than 5, and you update the traces. So these are the different directions, so the different traces, text equal to north, northeast, uh, okay, and yeah, so then there is also something known as dash, Plotly dash. If you would want to embed these plots in your website, or you would want to send your plot to somebody, so this Plotly dash you can use. So this is altogether a like different platform on its own, something like GitHub of for Plotly. Okay, so then we saw this already last time, the Cartopy library. So that we will, yeah. Fine. Okay, so I would say that if you guys want, I can cover